Hello, my name is Terpeluk. I was with Renzo Piano Building Workshop for 10 years and brought over here to head up the design and construction of the California Academy of Sciences. So here we are on the vegetated roof of the California Academy of Sciences, and below us, below this dome, is the biosphere of the rainforest. And you can see the array of skylights, circular skylights, which allow that sunlight to penetrate all the way through, down through the flooded Amazon rainforest tunnel into the public space below. Now the roof itself is envisioned as a piece of the park which had been sliced into a rectangle, lifted up in the air, and then draped over top of two spheres. One of the primary missions of this building was to unify or integrate the building and the architecture with the landscape. So here we have a view of the underside of the green roof, the living roof. And the structure is composed of a series of beams on a very simple 8-foot by 24-foot grid. However, when you superimpose an organic geometry on top of that structure, suddenly you have very complex structural beam systems. The method of fabrication for the beams was quite interesting. We had the entire assembly modeled in 3 dimensions, and then that was a CAD/CAM model which was sent directly into fabrication. And here you can see the curvature of the beams is a 2-dimensional curvature. So we have W21s running in the north-south direction to reinforce the entry, the curvature as you enter into the building, and then W18s, which are a shallower beam running on 24-foot centers in the east-west direction. And you'll see that there are a series of white panels sandwiched between the beams, and those are actually a very simple, standard Armstrong ceiling panel, which was arrayed across in a sort of fish scale pattern to reinforce the curvature of the roof and to reduce costs. And what we're seeing here is actually the grow out of the vegetated roof, which was 2.5 acres, which was grown off-site. So we developed a system of biotrays, which are composed of cocoa and bamboo fibers, and those are filled with highly engineered soil and 4 different plant species. And those were grown in Carmel Valley and then brought onto site and then assembled and tiled over the roof, almost in assembly line fashion. So this roof, after the first year of establishment, will not require any more irrigation. And the roof will retain 98% of the water from rainfall and from mist, and be collected in cisterns below the building, which will then be slowly replenish the aquifer. So we had to find actually the exact diameter which would allow the diaphragm integrity to remain intact, but also flare out the bottom of the skylight to maximize the amount of luminance in the space. And you can see the actuator, which is connected to the building management system, which allows those skylights to be opened during periods of high heat buildup.